Alright, so this video is going to be one of the videos to review concepts from Chapter 8, which was over quadratic functions. So if you remember, some of the topics that we worked on was factoring quadratics, factoring completely, solving by factoring, completing the square, and solving by completing the square. So this video is going to focus on the first of these, which is factoring quadratics. So by definition, factoring is to write an expression as a product. So this is not just for quadratic expressions, but for any expression when you rewrite it as a product. For quadratic expressions, when you are given a quadratic expression such as x squared plus 5x plus 6, the way that we learned to rewrite it as a product was to build a rectangle using those tiles. And then we found the length of the length and the width, and we rewrote that as a product of length times width. So x squared plus 5x plus 6, that sum is equivalent to x plus 2 times x plus 3. Now this is fine as a process, especially when you're starting off, but we wanted to come up with a more effective way to do these problems, especially when you have lots of tiles or negative tiles and things like that. So we learned the process of factoring quadratic expressions using our generic rectangles and our diamonds. So here's the process for that, if you recall. We place the x squared and constant terms of the quadratic expression in opposite corners of our generic rectangle. We determine the sum and product of the two remaining corners. The sum is simply the x term of the quadratic expression, while the product is equal to the product of the x squared and constant terms. We placed the sum and product into a diamond problem and solved it. And then we placed the solutions from the diamond problem into the generic rectangle to find the dimensions of the generic rectangle. And finally, we wrote our answer as a product. So let's see a few of these at work. So remember, the first thing is that these expressions should be in standard form before you start this process. So make sure you have your ax squared term first, followed by your bx, followed by your c. So let's try this one. Factoring x squared plus 6x plus 9. We consider this a more basic problem because the a is 1. We don't have a number larger than 1 in front of that x squared. So we're going to place that x squared in the corner, and across from it, we're going to place our constant term, 9. We're then going to find the product of the diagonals. What is 9 times x squared? It's 9x squared, and that goes in the product part of our diamond. Notice I use an x for a diamond. You can use a diamond if that's how you work best. Then we look for what is the sum. How many x tiles do I have? For this problem, I have 6 x tiles, and I'm going to have to split them up between the corners of my rectangle. Now I don't know exactly how many are going to go in each corner, so to do that I use the diamond problem. So I'm looking for two factors that multiply to 9x squared, but add to 6x. So when we're looking at factors of 9x squared, we have 9x times x, and we also have 3x times 3x. Which of these is going to add to give me 6x, 3x, and 3x? So those are my two terms. Those go in the corners of my generic rectangle, and then I look for common factors of each area. I'm finding the factors of each partial area in this generic rectangle. So my final solution would be factored x plus 3 times x plus 3, or you can write x plus 3 squared. Let's try another one. 2x squared plus 7x plus 3. 2x squared and 3 go in my corners. Make sure they're in opposite corners. I multiply those together to get my product. I look at how many x terms I have to get my sum. I'm looking for two factors of 6x squared that add to 7x. These are my factors of 6x squared, and the 6x times x is going to be the two factors that add to 7x. Those are going to go in the corners, and then I'm going to look at what are the greatest common factors between each length and width of my partial areas here. Once I've figured those out, I rewrite my area as a product, 2x plus 1 times x plus 3. Last one, I wanted to throw one in here with a negative, so we can see what happens with that. 3x squared and 5 go in the corners, looking for the product of my diagonals, which is 15x squared, that add to negative 8x. So this time I have negative 8x's. So if I have two numbers that multiply to give me a positive, but add to give me a negative, that's going to tell me that both of those factors are going to be negative, because a negative times a negative is a positive, and a negative plus a negative is going to be a negative. So my factors of 15x squared, keeping in mind that they're both negative, is negative 15x times negative x, and negative 5x times negative 3x. Between those two, negative 5x and negative 3x will be my two factors. And then finding my common factors between 3x squared and negative 5x is an x, meaning that this length is 3x, negative 1, and negative 5. So when I factor it, I get x minus 3 times x, 3x minus 5.